Good afternoon, everyone. Welcome to this edition of the NITheCS Micro School. My name is Dean Brand. I'm usually the host of the micro schools, but today I'm presenting as well. So for a quick introduction of who I am, my name is Dean Brand. I'm a third-year PhD student working at Stellenbosch University in the quantum research group run by Professor Francesco Petriccione, who's also my supervisor and the director of NITheCS. My research is on quantum neuromorphic computing for AI. But today I'm going to be talking about something a little bit different and more focused on software engineering and development side of things. And is mostly just a very useful tool to make life a lot easier when dealing with sharing code and putting code on web servers and things like that, that you might have encountered. You might have encountered a place where this will really help, which I hope is the case. The software is called Docker, and it is a industry standard used pretty much everywhere, especially in enterprise code and production environments. And yeah, for many, many reasons, you'll see why it is almost unthinkable to work without it past a certain level. So for getting started, I will just speak a bit about the use case for Docker and why it's so useful and why I harp on about why it's so important to have. So if you've ever dealt with this, then you will sympathize, but otherwise just imagine along for the scenario that if you have code that is running on your computer, on your laptop, is working well, you've got your complex Anaconda configuration working, and you've got your databases installed and all of the Python packages, pip installed or Conda installed, that's been building up throughout the project that you've been working on. And everything runs just fine. There were some bugs that you encountered along the way, but things run perfectly fine now. And then someone like a colleague or a supervisor or anyone asks for you to share the code. And then they try and run it and it doesn't work. And it's the exact same thing. You give them all the installation instructions, you tell them which packages to install, you give them a requirements file, but it just doesn't work. And it's some weird bug somewhere in their computer not having the exact right configuration or setup that yours does, or some strange incompatibility between operating systems, or maybe you were developing on Windows and they are on Linux, something like that. And it just doesn't work, even though there should be no reason why, because the code is as good as you can make it. You can't find any bugs because it's working, but they find the bugs. Or for a similar case, if you've developed a nice web app or a nice project or anything that you've been working on, and suddenly you want to then put it onto a web server, onto something like AWS or Microsoft Azure or something like that. Sorry, Martin, I just to let you know your camera's on if you didn't intend to have it. Yeah, so if you want to deploy your code onto a web server somewhere, then let's say you've been developing it on your Windows system and it's been very well set up to work with how you've configured things, but then you try and deploy it on a web server and it doesn't work because the operating system doesn't have the same niche setup that yours does. So Docker avoids that by essentially packaging a full program, a set of code with all of its dependencies, with its operating system, with everything that it could need to run on. You might think that this sounds similar to doing it on a virtual machine, but it's not quite the same thing, because with the virtual machine, there's actually a good figure that I want to share here to show the difference. With a virtual machine here on the left, you have your host's operating system. It's got its hypervisor set up, which is the platform that configures the ability to have virtual machines. And then each virtual machine has a full fat operating system with all of its binaries and libraries and all of the little installed packages that come built with it, and then your code. And that is a lot of overhead, that is a lot of bloat, a lot of space that takes up a lot of resources as well, because it needs to be set up on the host system that a virtual machine has is carved out, set aside number of CPUs, amount of storage, amount of memory that's set aside just for that. Even though it might not fill all of that, it's set aside that way, and it makes things hard to set up efficiently. So what Docker does instead is it only puts your app or your program, your code, into what is called a container, a Docker container. And that is then built on top of all of the binaries and libraries, on top of a host OS for whichever server it's running on, for whichever computer it's running on. Like on my computer here, this is a Windows desktop. but I can have a container here running with a certain version of Linux. I can have to run a Python code. I can have another container running a different version of Linux or a different version of Windows, or possibly even, not sure how, but possibly something like a Mac OS with all of the licensing and all of that sorted out, running its own code there with its own necessary dependencies and libraries without needing to carve aside all of this big chunk of a computer or set up a virtual machine and have this full fat desktop. Like I don't need an Ubuntu interface at desktop to be able to just run the code, and that takes up a lot of space. But a Docker container neatly packages everything of your code with the necessary operating system, a very slim one as well, a very just enough to kind of run the system and be secure. And then with the little bits of extra libraries and packages that you might need. And with this, I can give someone just the Docker container. I can put it onto any server, any computer that has it, any web server. As long as they have Docker installed, then it'll run it in exactly the same way as configured to run. It will be actually shareable as it is intended to be, but without all the weird little bugs and quirks that come along with trying to share code and the actual system that it's running on. So for this, Docker has become an industry standard just for the consistency of how code can be shared and can be run in the exact same way that it needs to be. Also, a nice feature of it is that you don't need to really technically install anything anymore if you just have Docker. And I'll show you what I mean soon. For the main introduction to Docker, you can go to the Docker website, and where you'll be able to see all of the different things that it can do and the features that it has and all of the different offerings that they have. It might be a little overwhelming because there's a lot of things that they offer. They offer the AI, different products, Docker Desktop, Docker Hub, Docker Scout. We don't have to worry about all of those things. For now, you just have to worry about downloading Docker Desktop and getting it started up. As a small caveat to this, Docker is quite dependent on the Linux, or at least the Unix-based systems for how it does its containerization. So if you're running on a Windows machine, you will need to have Windows subsystem for Linux installed. It should be quite easy to get up and running if you don't have it already. Just search for Windows subsystem for Linux, or WSL, and there's a very easy installation guide. It's a few command line commands that you have to run, and that can be set up very easily. But then you just download Docker Desktop, and you can get started with that. It will end up being, let me share a screen to show what the actual application looks like. Once you have it installed, then it'll be basically this application that has mostly just an empty screen with some little learning center blog posts that you can have a look at, but more will cover all of those within this. It has images, volumes, Kubernetes, and builds, and that's all you really need to know about. Mostly for now, containers and images are what we will be concerned about. Because it might get a little strange with all the terminology, you'll get used to it, but for now, this is supposed to be just a gentle introduction to that. So for container, I've already explained that it's just a nice bundled version of your code that comes with all of the dependencies, all the libraries, and everything else that you might need into it, with an operating system that can run it. And you can move this container kind of anywhere. It's a fully portable system. As long as they have Docker, then they can run it. You can imagine it as if you are going to visit a friend's house, visit another country with a hotel, something like that, and you bring your sleeping bag, you bring your dinner, you bring your backpack, you bring your own bath and shower. You don't need anything that's already there. You already have everything built in as you would need it. And that can make it a lot easier to be moving around all over the place and not dependent on where you are set up or where the host is or what is the underlying rest of it. That shouldn't have an influence on the code, but that everything that the code needs to run is portable and can be sent wherever. So just to go back to the website, on this main Docker site, you can download Docker Desktop. You can get started with it like that. There's a even easier introduction page here that you can go through to see all of the different things of what it can do and the little guides if you want to dig deeper into things. As always, it does have very good set of documentation and a lot of getting started guides and manuals and reference to get into more of the intricacies and see how you can set it up for your use case. So now this will be a very general, just broad introduction into the little quirks that every Docker use case will have, and then you can customize it to your use case. For an example here, one of the intro guides is setting up Docker containers for data science with Jupyter Lab. So you can have your Jupyter notebook and do all your data science things that you would in Python, as we've shown in previous micro schools. I chose this example. And it gives a very clear guide on how to set everything up and all the commands to run, and a very easy way of setting something up like this that you don't have to install Python even. You don't have to install any of the libraries. You don't have to install any of the data. You don't have to install Jupyter or Anaconda or anything like that. You can just run it in a Docker container like this. That's what I mean with that you don't have to install anything. You just run the Docker containers and the images like this. Speaking of what an image is, instead of a full running container, an image is just a blueprint of what that container will be. So for an example, we can look at here at the Docker Hub registry. You can think of Docker Hub as GitHub, but for Docker containers and Docker images. That it is a collection of all the different pre-made versions of images that you might need, and where you can put your own code. For an example of something like that, instead of just seeing code bases like that, you can even look on GitHub and find the source code for something like Python. Same thing here on Docker Hub, you can find the Docker image for Python. So here, I'll never have to install Python as just going through the Python website, downloading, installing, and having it on my system, and then going through all those upgrades. I can just pull the Docker image, create a Python container, and then run Python only within Docker. That is only then configured to run with the Linux image that I choose for it, and that it was always predictable and the same use every time. That it doesn't have to be, or that I've got Python installed from Anaconda and it's version 3.9, and then there's another Anaconda version on my another Python version on my computer that's running Python 3.13 and installed through the Python website, and then those are clashing and there's confusion. This way, everything is neat and tidy and clean, just set up to be whichever Python version you want with the system in your Docker container. So I will show how all of this works now in a real case, but I just wanted to run through those pages so that you can have a look at Docker Hub and the Docker documentation to see everything for yourself if you want. But for now, let's move to command line, so I can show you what the different commands are to interact with Docker. You can use the UI, but a lot of it will be done through a command line. For an example of just what to do, you can just run Docker and then see all the different commands that you can run with it, with a little guide on it all. But the main first example, we can do Docker run hello world, just to show that it's working. It'll say that it can't find it because I haven't installed it yet. And then it will pull the Docker image. Let me make this just a bit easier to see. It'll run the Docker, pull the Docker image from Docker Hub, and then run this hello world container that Docker ships quite easily, just to see that it is working, that it's installed. So you can test this as well. After you've installed it, you can just run this Docker run hello world, and then you will see that it is working. For then to see where do we go from here, the main things that you will be using it for is to look at things of seeing which images do you have, which containers do you have running. You can very easily list Docker images, and then you can see, okay, this is the only one that I've got running here is this hello world. It's the latest version of it, and it was originally created. This latest version was pushed to Docker Hub 5 weeks ago, and it's got this size, and it's got an image ID to be able to reference it a bit easier because you might have different versions of it. For Docker containers, you can run the same thing, I believe, or no, it's Docker PS, which is process source or something like that. I forgot the name, but just Docker PS is the same as your ls command, which will list all of the active containers that you have running. So here we can see the difference between images and containers. An image is just your blueprint of what the container will be like, and a container is an actual running version of an image, an instance of an image, an actual application or a bit of code that is currently running. There aren't any running because the stock run a hello world actually is just a print message, it prints and then it stops. So now I would like to show how we can make our own image, because, okay, for an example, actually to see how to interact with a direct pulling of an image, something like the version of Python, I can say Docker pull Python 3.13-slim. This -slim is just a very, very bare bones version of a Debian Linux distribution that doesn't have almost anything installed. It can start Linux and it can run some code. And this Python version just comes bundled with that. So it's pretty much only got the very basic Linux distribution and Python 3.13 on it. And that is a main image that we can use. I can pull that and then it will go through this. It'll do its hash check and then we'll have the image listed. As now we have hello world and Python 3.13 slim. And then whenever we want any different Python versions, we could just download different Docker images or pull different images and then use those when we need to. So now I can show what does it look like when we actually are dealing with something where we are making something in Docker. So here I've just gone to my Visual Studio Code with a very, very, very basic version of a Python app and then the Docker files that go along with it. So this Python app, it's the most basic I can think of, is just it prints the hello world, hello from Dockerized Python with the Python version that we'll be running it on. And it comes with a very basic requirements file just to show how we can do the usual pip install process. Yeah, it's just got a NumPy because we won't actually need it, but it's just the first that came to mind just to show how we can actually use the requirements file. Then the main Docker files that we will need, similar to GitHub with a git ignore, we can have a Docker ignore that just tell Docker to not even bother looking at these files because they're not going to be relevant to the actual program that we're building. They're just relevant to the development process. Like if you have a virtual environment or you have a Git or you've got some PyCache that Python already automatically made these files for. So this Docker ignore just ignores all of the different files that it doesn't need that are in the workspace. Now, the main meat of things is here in this Docker file, and it doesn't have an extension. It is a bit of a unique one in that case. It doesn't have a .doc or anything. It is just Docker file with a capital D every time for whichever your workspace is, whichever your folder is. Maybe you've got a running, just Docker file. That's what it needs to be called because that's what Docker then recognizes when it is looking for how to build this image. And then it's just got this list of commands, rather from, env, vector, all these things. It is set up with a very specific structure like this, as you can read it from top to bottom, as the order in which things are done, corresponding to the layers that Docker has. Because when Docker builds something, it builds it with these different layers of the application. And these different layers are different commands. Because if you imagine that you made one small mistake in your Python file, and you need to make one small update, then you don't want to have to go and reinstall everything and reinstantiate the operating system and go through everything, but you only want to update the line in the file that you changed. This allows you to do that because then it caches all those other layers and it only then updates the ones that you've changed. So if I change one line in my Python file, then I would only need to update this final Python run app.py instead of having to do all my installation of the packages again. So let's just go through this line by line and see why the order makes sense in this case. It'll always start with a from, which chooses your base image of what your operating system will be. And this operating system, we can see it as is the base image of an operating system of Debian Slim. There's Alpine, there's Trixie, there's all sorts of different ones. And then that only has then Python 3.13 installed onto it. This env line here is more just a quality of life improvement, where this Python don't write bytecode just tells it to not make its own cache files because it doesn't need to make Python cache files because it's not going to be regularly being run all over again, that it needs its caching for when it does its Python running stage. That's more just a development thing, but yeah, we can turn it off. And the same thing with this Python unbuffered, that just clears the log files so that the logs happen in real time. So when you look at how your Docker file is running or your Docker application is running and it is giving log files or print statements, then you just see it in real time as things are happening rather than it being some optimized, some batching process. So this is more just a quality of life thing. Then we set it to our work directory because you can imagine it's a fresh operating system. Now we want to say, okay, where's the actual code, the files happening for this case? You can set things up for different work directories and different directories going on for other parts of the Docker file if it becomes a more complex application. But for now, we'll just set it for this app directory. We copy over our requirements txt from the host, wherever you're running it, from this Docker file, from this directory on your host computer, into the container. Because the container is quite empty just from having its only instantiated the Slim operating system distribution, and you made an app directory. You copy the requirements file, then you need to run your installation of the requirements. This line might look a bit confusing, but I'll break it down for you. This might seem a bit confusing with here talking about that it wants a cache and then the next line saying no cache. So what that actually means is that this top line of the mount type cache and setting all this up is actually just for Docker itself to keep a cache of the Python packages and libraries that you have installed previously, so that it has its own cache to work from, but not then setting this no cache directory makes it that in the actual container, it doesn't have a cache and all the Python wheels and everything required to build in the actual container itself. It keeps it just in Docker, but not in the container. So you save a lot of space because you don't really want to be sending around very big bloated programs when you are sharing the built Docker container or the image. You don't want someone to download an image and then it turns into this 100 gigabyte Python file because it's just got all these Python files and Python directories and cache files baked into it. You want it to be quite slim so that it's more portable. So this is just quality of life things that set that up. But mainly it boils down to your pip install -r requirements. So it installs all the required packages. Then once that's installed, you can copy all the rest of the files into it, which then this is where it comes into keeping the layers separate so that you don't have your app already copied over and then you change one line of Python and then it runs all of the installation steps. Yeah, we can try and keep it from top to bottom as they keep it on a process of the bottom ones are the ones that are not replaced very often and the top ones are replaced very often. So you try and set up in that hierarchical structure where the ones you will replace the most or change the most are closer to the bottom here to organize the cache nicely, because it will rerun all of the ones after a line that is changed. So the three final two lines are to just copy over all the other files and then to set up this cmd python app.py. It might look a little bit strange because if you're used to running Python from a command line, you just write Python space app.py. But here you can't just do the spaces on it because it sets it up as how your command line breaks it up behind the scenes, as taking the spaces as to then split it up into those different commands. And then you can put in your flags and you can put in the different subcommands and the different file structures. But for an actual command is just a list of those words and instances. So it's a little bit of an adjustment, but once you get used to it, it's quite clear, quite easy. And you won't have to worry about all of the syntax of this. It's usually very, very good structured ones that are online that you could just find the Docker file, you change one or two lines that you need to, change the amount of your app, change the order of something, that you won't have to rewrite this from scratch every time. And very fortunately, because there's so many Docker files out there, because it's so ubiquitous in the industry, LLMs are also very good at making Docker files for whichever thing you're running. So you open up a GitHub Copilot and you say, make me a Docker file for how to run this app. It'll do it quite well. So it's just not something that you have to memorize the syntax of Docker files, the same as like bash scripts. It's mostly you can find the ones that you need are already done and out there. So once this is now done and set up for our Docker file for this project, then we go back to command line and I can show you how it can be run. So once we have this now, we can essentially build our file. Let's just look for the right set of commands that I wanted to show. Yes, that's a very basic simple one for this. It is just Docker build. You can put in some other flags, but we don't need to. Docker build hello Docker. That's the tag that we're putting onto it. The tag is our name. for this, that it's not just app, because everything will just be app, but we call it Docker, hello Docker, and we're saying to build it here. Then it will go through this whole process of going through every step of the build process of getting the metadata, seeing the Docker ignore. It uses the Python image that we pulled earlier. You can see here that we're setting all these stages. These things are cached from earlier because when I was testing this out, then it sets its work directory, it copies the requirements, then it runs this pip install in the right order, and then it gets all the layers, the manifest, the config to do all the hash checks, and then the build gets complete. Then once this is done, I can just run Docker run hello world, hello Docker, and then also hello from Dockerise Python, and give me the version, which is this Python 3.13-slim. And that's pretty much it. Then I don't have to have had Python in my system. You can even see in my CLI that my Python installed in this shell script, in this shell is 3.11, but for Docker, yeah, Python is installed there, just 3.13. And I can do this with anything. You'll be surprised with what you can find has an image on Docker Hub. Even things like the most painful that I've had to deal with is installing different databases, things like Postgres or MySQL, things like that. You don't ever have to install those and set them up and configure them and all the different versions of it, and the community version and enterprise version, all that. You can just run Docker pull Postgres and then you just use your database as a Docker container. As an example of that, then I'll share one further thing that is not really the intention behind this lecture, but just as a very basic example of what it might look like, because it does take a little bit more tweaking. Here, for an example, because this Python app is very basic, it's just print statements, but if you had something that interacted with the database and pulled data from there and then ran a web server based on that and could deal with users and things like that, then you might need something like a database that's already running. So instead of then having a database installed on your computer that you somehow then have to ship into a web server or into a cloud instance, then you would rather want a Docker container running a database that can communicate with the Docker container of your app. So as an example of what that looks like, we have this Docker Compose idea. And Docker Compose is just essentially, it's a way of orchestrating your containers into putting them into this setup where they can actually communicate with each other. Docker Compose is always docker-compose, and it is a YAML file. And it's also just like a Docker file in your directory, and you can run these services using this. And it is set up with the YAML syntax. Again, you can find very good examples online of pre-built or pre-set up Docker Compose files, or again, LLMs are very good at it. You don't have to worry about getting the exact syntax perfectly right, because YAML files are notoriously difficult to work with. So there are good examples that you can find. But essentially, here it sets up for the app. It builds it from your Docker file and runs this Python app.py. It sets up an environment just here so it can communicate with your hypothetical database, and has a volume for persistent information. Because if you think you're running a Docker container on your computer, but then what happens if you turn the computer off? What happens to the container? It can pause and persist the information that you're working with, that it doesn't just disappear and get wiped out when you turn off your computer, but that it can actually save it to a file somewhere. And then same thing when running your database. It pulls this Postgres version 16. It sets up with the user and password and the name. Obviously, you wouldn't use this for actual production database, but this is just as a very basic example where you can set up the environment variables. You can configure the ports so that it knows how to communicate to it and which port to turn to when communicating with this database. And then it's persistent volume. And then you can set up again this persistent volume in this stage. It might look a little strange, but it makes sense in the YAML Docker Compose world. There's more resources online to find out why. I don't even really know why. I just know that this is how it's done. And you just stick with that. So that's how you can get all of your programs and apps working together without having to install anything, and you get it working perfectly coordinated in this way that everything works on Docker. Then you know it will work everywhere. If it works on Docker on your laptop, it'll work on someone else's. It will work on some web server. Everywhere that there's Docker, it will work. There won't be any confusion about the way that you've set up your app or the way that you've downloaded different things on your computer or your operating system or version conflicts. It will always just work the same everywhere. And hopefully this saves you a lot of time. Hopefully you've never had to encounter the difficulty of doing these things without Docker, but I hope that you can incorporate this into your workflow somehow that it's already clear to you how you'll start using this and how you'll be able to package and ship your code much easier using this. That's about all that I've got to share, and I realize I'm just a little bit over time, so I think I should turn to ask now if there are any questions that anyone has. Yeah, didn't see anything in the chat, so if there's any questions, feel free to unmute your mic and ask.
I have a question, and thank you so
Yes.
much for your presentation. It was really informative. So it's about the volumes. Is the volume attached to the container? And if yes, then what happens when you delete the container? Does the data still persist in the volume, or does everything just get deleted?
I haven't encountered that directly, but I believe it is attached to the container in a way that usually it's the other way around, where you'll keep a container, but you'll delete a volume. But I believe then if you delete the container, it'll delete the volume as well. There might be a way of sparing the volume or exporting it. I'm not sure. I'd have to research that. I haven't done that before, but I believe it is quite composable. So you can split one apart from the other and keep a volume safe while you delete the container, or the other way around. But I believe they are packaged together in that way. In the Docker Hub or the Docker desktop app, if I can just show you that again. Here's the right screen. You can have your volumes here that are persistent. So here are from containers that I've run and deleted in the past. They were made a couple of months ago, a couple of weeks ago. Those are volumes that you can just interact with directly. So yeah, I think they should persist either way then. So it's just not something that I've dealt with often, but it looks like, yeah, they do persist wherever they're created. And you can delete those separately, you can copy them, you can keep them, probably reattach them to different containers. Yeah, so that answers.
Thank you.
Sure. Are there any other questions from the audience?
Hello.
Hi there.
Yes, from my side, just to thank you for the wonderful presentation. It's the first time for me to interact with Docker. So I think I just need a bit of time to try and go through and see how it works practically. Otherwise,
Sure, yes.
if one question is, if I was to make an application or an app, let's say in teaching, I teach statistics and mathematics. So if let's say I develop if I want to develop an application, can I use Docker for that?
Yes, it's supposed to be, if you're developing something that then turns into an executable file or some actual desktop application that someone wants to run, then you can compile that and build that wherever you like. It's easier to use with Docker, just to make sure things stay consistent and nicely packaged.
Okay.
And that you can share the images with them so they can build it themselves. But if you're just sharing an executable file, then that you can share however. It's the same idea of an executable file, you can't change the code, it just works. Similar with Docker, it's just going to work. Someone can have the code that they can take themselves, they can pull the Docker image and then just interact with it like that, through however you interact with a program, probably through a command line interface or something, and then it'll work quite nicely. With that, Docker makes the development process just a lot easier also than for sharing code or for putting it anywhere else, just to take it away from whichever strange nuances there's going on in your operating system or your computer that is running other things that might conflict. Like I've had horrible experiences with Anaconda, and how that somehow influences and causes bugs for completely separate applications somewhere in my computer, just because Anaconda was somewhere in my file system. So this prevents that from happening altogether.
That's right. Thank you so much.
Sure.
Hi, thank you for the presentation. It's Gavin speaking here. So
Okay.
I came in a bit late. Maybe you mentioned this when you started. Is it true that to run Docker on someone else's computer, so like I make an app and I containerize it, do they have to have Docker on their computer for it to work?
Yes, Docker is the one consistent part that allows for this interaction between the apps. But Docker luckily is very easy to install, and most people should have it. If you're dealing with developing code a lot, then Docker seems as common as you would have a code editor.
All right. Okay. Thank you.
Sure. Yes, Faith, I see you've got a hand raised.
Thank you. So I have this issue where I'm running my application in areas where they have internet access and areas where they are offline. So I understand that I need Docker installed in the areas where they're offline. But my question is there a way that the application, because they will have to input some data, is there a way that the Docker that is offline can be synced the data that they have entered with the Docker, the application that is running in the Docker that is online? Any advice with that?
Yes, I think if I understand correctly, you only really need to share the data once and they can run the Docker locally. Docker doesn't have to be an online thing. It is even the same as, like, similar how there's Git and there's GitHub. You can use Git just as your own version control within your own application, completely offline, just on your own computer, just to keep things ordered and structured. GitHub is where you can share it. Same with Docker, that you can build the containers just to see that it can build and that it can be nicely containerized and separate from all of your other everything else on your computer. So if I've got, for example, a database that's running and I don't want to install it, if I've got some code that I know there's some Python packages that only run on a Linux system, but I've only got Windows, instead of having to go through something like installing a Linux virtual machine or something like that, then I can just have a Docker image for a Linux Python and run it just in that container without ever having to interact with the putting it online or something like that. As long as you can download or pull the Docker image that you want to use, then it just isolates your environment that you're building in. So I'm not sure if it's at least possible to get the data and then to get a Docker image, then they can run everything locally. But that's the same thing as just having to say that you have to install Python from the website. So you have to download it, or you have to download a Python package when you pip install something like your pandas or something. So I'm not sure how that would impact your work, but I hope that it clears up that it can be fully offline. It's just an app that you download and to make your workflow a bit easier.
Cool. Thank you so much.
Sure. Any final questions? I think we're running a little bit over time. Maybe fit in one more, please. Okay, it seems not. I think now is a good time to let you go and explore Docker for yourself. And then if you do have any questions, then you can feel free to email me. I'll put my email just in the chat, so you know that. So yes, if there's anyone that has any questions about anything like that, or you have any ideas for micro schools, or you have anything that you'd want to present or want to see, we are always very open to more ideas for micro schools. So please feel free to let me know. And I hope that you have a good experience with learning about Docker. There's a lot of information online, a lot of YouTube videos, a lot of documentation. LLM is also very good with it, but I hope that this was a nice introduction to see that it's not too intimidating and it can be very useful. Even just what you've seen today can be very useful for your workflow, for code management, for sharing code, anything like that. Yeah, hope you enjoyed, and I hope that you enjoy the rest of your Friday.
Thanks, and same to you. Bye-bye.
Thank you. Bye, everyone.